Okay, should I begin then? Right, criminal career research. I think the criminal career approach is really quite an exciting perspective in criminology. It was stimulated by the National Academy of Sciences panel on criminal career research, which I was a member, which was chaired by Al Blumstein, and this panel reported in 1986 in a document called Criminal Careers and Career Criminals. Basically, the criminal career approach is not a criminological theory, it's a framework within which theories can be proposed and tested. Really, a criminal career is defined as a longitudinal sequence of offences committed by an individual offender. So, criminal career does not refer to making your living from crime, as has sometimes been used. It really refers just to a sequence of offences committed by an offender. Some of the key concepts are in this overhead, and I'll go through some of these in the next hour or so. Some of the key concepts include prevalence. That really means what proportion of the population commit offences, leaving aside definitions of offences, which I'll talk about in Section 2. Section 4, the individual offending frequency. This refers to the frequency of committing offences by offenders. So for those who commit offences, at what rate do they commit them at? So many offences per year is the usual measurement. Number 5, onset. This is the criminal career has a certain specified discontinuous onset. It starts at a certain age. And we have desistance. The criminal career ends at a certain age. Again, a discontinuous ending of the career. Chronic offenders, a special topic within criminal careers that I'll talk about. But duration, this refers to the time between the onset and the desistance. Criminal career starts at a certain age, it then has a certain duration, then you have desistance at the end of the criminal career. Continuity really refers to the extent to which individuals who are high-rate offenders at one time continue to be high-rate offenders at a later time. It's really referring to individual continuity over time or over age. Specialisation, another topic within criminal careers, the extent to which people specialise in committing certain sorts of offences. And a related topic, which I didn't put up, is escalation, the extent to which people gradually commit more and more serious offences during their criminal careers. Or de-escalation, the reverse, the extent to which people commit less and less serious offences. There hasn't been a great deal of research on escalation or de-escalation. Been more on specialisation versus versatility in offending. And then some other special criminal career topics I'll mention towards the end: co-offending in criminal careers and motives for offending. One of the key distinctions in the criminal career approach is between prevalence and frequency, between numbers 3 and 4. For example, you may be familiar with the age crime curve, which looks something like this. We can have an artist's impression of the age crime curve. It rises to a peak in the teenage years. This is the aggregate crime rate. This is age. You'll all be familiar with the fact that the age crime curve rises to a peak in the teenage years and then drops off. The key question addressed by criminal career researchers is this a peak in numbers of offenders, i.e. in prevalence, or is this a peak in frequency of offending? Because either could generate this peak. It could either be that you have a lot of different people committing offences in the teenage years, or it could be you don't have any more offenders, but each offender commits more offences. Of course, it could also be some combination of that. This kind of an issue is very important from the point of view of policy in knowing whether you've got more offenders or more offences. The same sort of question can be asked in regard to aggregate increases in crime rates. For example, if you find crime increases over time, is this because you have more offenders in the population, more prevalence, or is this because you don't have more offenders, it's just that the average offender commits more offences? There's a key feature in the criminal career approach is to try and develop explicit mathematical models and to test exact quantitative predictions. I will spare you most of these today, but I will just give you a flavour of it on one or two occasions. The aim of most researchers is to try to propose models that are simple, very simple indeed, but that explain the observed criminal career data, such as the number of offences committed by different people or their rate of offending. The basic idea in virtually all these models is that offences are committed according to a chance process, according to a probabilistic process. And the key concept, which I might as well explain to you, as I say, I won't go into mathematics, but the key concept which has been popularised by Al Blumstein is the idea of the individual offending frequency being lambda offences per year. The lambda is used because of using the Poisson process and the Poisson distribution, which typically uses the term lambda. But all Blumstein means by lambda is the rate of offending by offenders, average number of offences per year. So, for example, if lambda is 10 offences per year, one may also assume there's a certain probability of being convicted after each offence. Let us say if lambda is 10 offences per year, probability of conviction, p might be 0.1, then on average each person will be convicted once per year. You merely multiply 10 offences per year, probability of conviction after each offence of 0.1 gets you on average one offence per year. However, because of chance processes, sometimes, well, such as the occurrence of criminal opportunities or the chance of being caught by the police, which may be a very chance activity, some people may have two convictions in some years, no convictions in others. And the point is that assuming that convictions occur probabilistically or according to chance, you can specify the probability of having no convictions, one conviction, two convictions, three convictions, etc., according to the Poisson distribution. And most of the criminal career models are based on this, at least when they go into the mathematics of it. It's a familiar distribution. If you've done any mathematics, you'll be familiar with it. As I say, it's basically the ability to make quantitative predictions based on the idea of offending as a probabilistic process. We move on to definition and measurement. As I'm sure you'll be aware, the most common measurements in criminology are through official records and self-reports. Most criminal career research is based on official records of convictions or arrests. And the reason for that is because it requires exact information about the timing of offences. You need to know when offences occur. This is available for arrests and for convictions, but usually not for self-reports. Usually with self-reports, all you know is that the person admits that he or she committed so many in the previous year or whatever. It may be possible to get offenders to keep a diary listing all their offences, but I don't know whether that's going to be feasible. Ideally, we'd like that to get valid measures of people's offending. But so far, I think self-reports have not really been adequate for criminal career research, and that's why the research is based on official records. I think the effect of that is that official records are reasonably adequate for estimating prevalence. Generally, official records and self-reports agree reasonably well in the prevalence of offending, at least for serious offences, relatively serious offences. Official records are reasonably adequate for onset and desistance as well. We seem to get reasonable agreement between official records and self-reports for these quantities. But I think official records are least adequate for estimating frequency, because all the evidence would suggest that offenders commit many more offences during a given time period according to self-reports than according to official records. So I think the effect of basing criminal career research so far on official records is to underestimate the individual offending frequencies. But I think the data on onset, desistance and duration and prevalence are reasonably okay. But obviously something for the future will be to try and get better data using self-reports and to develop and test criminal career models using self-reports. Let me move on to prevalence, and I'll show you some data from the longitudinal study which I've been involved in, which I'll talk about in more detail this afternoon. We can see it. Actually, it's rather small. But basically what this shows is a number of different offenders at each age from 10 to 31 in the left-hand column. So you see at age 10, 6 of these males were convicted. This is a study of 411 London males. 6 of them were convicted at age 10, and then the number of different offenders convicted increased steadily to a peak at age 17 when 46 were convicted. 11% of the males were convicted of criminal offences at age 17, and then number of different offenders declined until at 31 there was only 12 convicted, 3% of the males convicted. This is a fairly familiar age crime curve, but this is based on number of different offenders at each age, which is a measure of prevalence. Typical prevalence curve. Self-report studies actually show similar peaks of offending in the teenage years, typically between 15 and 19. The peak age actually was 17 for the most common of types of offences of vehicle theft and burglary and shoplifting and theft from vehicles in this study. Violent offences peaked a bit later at 21, fraud later still at age 23. However, again, this shows a common feature of criminal career research. All types of offences are rolled together. So in this diagram you have all types of offences included. Basically these are all offences leading to records in the Criminal Record Office. But as I say, you can look at different types of offences, but typically in official records you don't get enough of each type, which is why people roll them together. Again, if you have self-reports, then you might be able to study each type more separately, because then you'll have enough offences to study. Also, moving on to the next topic of individual offending frequency, this table shows numbers of offences committed at each age. So you'll see that at the peak age, 17, 69 offences leading to conviction were committed by these males. So the 46 different offenders committed 69 offences leading to conviction. And that decline, it increases to a peak at 17 and then declines. You can't really just divide the number of offences by the number of offenders to get the individual offending frequency, because some people who have embarked on a criminal career, who have had an onset, but may not necessarily have an offence leading to conviction in a particular year. So, for example, if a person's rate of offending or rate of conviction is 1 per year, then there's a certain probability that they will have no convictions in a particular year. According to the Poisson process, you would predict that the probability of this will be about 0.37. So if your true offending rate is 1 conviction per year, then 37% of the time you will have no convictions in a year, assuming that convictions are generated by a probabilistic process. So as I say, you can't just divide this by this to estimate the individual offending frequency. You have to try and determine when onset occurs for offenders, when desistance occurs, therefore which offenders are currently in the middle of a criminal career, and they are the denominator in any calculation of individual offending frequency. What I was involved in quite a bit of research with Arnold Barnett and Al Blumstein, trying to test mathematical models to fit the criminal careers of our London males, and we found it was inadequate to assume that all the offenders had the same frequency of offending. We started, our strategy throughout was to start with the most simple possible models, then see how far you had to complicate it to fit the data. And we started off assuming that all offenders had the same rate of offending over time, the same individual offending frequency. We found that this was inadequate. We couldn't fit the data with this assumption. However, assuming two categories of offenders, which we called the frequents and the occasionals, because the frequents had a relatively high individual offending rate and the occasionals had a lower individual offending rate, we could get a good fit to the data, that is, to the longitudinal sequence of convictions. And for example, what we found was that for the frequents, the conviction rates for the frequents, if I call that the mu of the frequents, that was 1.14 convictions per year. And for the occasionals, the mu of the occasionals, that was 0.41 convictions per year. What that meant was that the average frequent offender went 10.5 months between each conviction. You see, it's just the reciprocal of this. You divide 1 year by 1.14, convert it into months, and a rate of offending, individual offending rate of 1.14 per year converts into a gap between each offence of about 10.5 months, whereas for the occasional offenders, who only have 0.4 convictions per year, there's a gap of about 29.3 months between each observed offence. And so, as I say, by assuming that you have two categories of offenders, the frequents and the occasionals, we were able to fit the data fairly well. Now, that's a simplification. I mean, we're not suggesting that in reality there are really only two categories of offenders, but what we're saying is that by making this assumption, we can fit the data pretty well. Generally, most studies of recidivism use reconviction or no reconviction within a short follow-up period of, say, 2 or 3 years as a key dependent variable to be predicted, but this is a rather insensitive measure. If people tried to measure individual offending frequency and associated time intervals between offences, like this, as I say, the time intervals between offences being basically the reciprocal of the individual offending frequency, this would be a more sensitive measure. So in other words, if you were trying to evaluate the impact of penal treatment, you could work out the person's individual offending frequency before treatment, you could work out the frequency after treatment, you stand a much better chance of detecting treatment effects than if you merely work out whether there's a reconviction or no reconviction, which, as I say, rather insensitive. And often one reconviction doesn't mean anything either. It might be better to know that there's a decrease in the rate of offending afterwards compared with before. Also, from the point of view of a sentencer, it would be very helpful to know the average rate of offending of offenders and hence the predicted time to the next offence. I mean, if you were a judge, you'd like to know for different offenders what is their predicted time to the next offence, which is what you would know if you calculate their individual offending frequency. Moving on to the next topic of onset, again this table shows numbers of first offenders at each age leading to conviction, and you see this really peaks between ages 13 and 17. The highest year is actually at age 14, but you'll see most people in this study are having their first offence leading to conviction between ages 13 and 17. So that's a kind of an onset curve relating the onset rate, if you like, relating it to the whole population or the whole sample of males. You can also calculate what's called a hazard rate, i.e. relating the number of persons who have an onset to the number of persons still at risk of onset, that is, excluding those who previously have had an onset of offending. And when you calculate a hazard rate, you see a clearer peak at age 17, because at age 17 fewer are at risk, fewer are in the denominator. If you were trying to develop a mathematical model of onset, you would obviously notice that the measured age of onset, let's call it A, was some function, was the true age of onset plus some variable x, which will be the time interval between the true age of onset and the age of the first conviction. I mean, we observe a first conviction at age 13, but for those first convicted at 13, it's likely that they started their offending careers before 13. In fact, it's certain on any reasonable model that they started their offending career before their first conviction. So we might be interested in estimating this quantity x, basically the gap between the true age of onset and the age of the first conviction. And we can estimate it by 1 over lambda, where lambda is the average rate of offending. So 1 over lambda being the average gap between offences and also the average gap between the true age of onset and the age of the first conviction. And so, interestingly, in our data, while the frequents and the occasionals differ in their rate of offending, and the observed age of onset is earlier for the frequents than for the occasionals, when you work out the true age of onset, the two are almost identical. What you see is that if they have an identical age of onset, the observed first conviction of the frequents is earlier. Remember, the average gap between offences is only 10 months, whereas the average gap between offences of the occasionals is more like 30 months. So you observe the first conviction of the frequents earlier than of the occasionals, but when you apply this kind of an equation, you find out they have exactly the same age of onset, which is counterintuitive, and that's often the case when you start doing mathematical models, thinking about what's really going on. As I say, the frequents and the occasionals in our data differ in their rate of offending and their individual offending frequency, but they seem to have exactly the same age of onset, true age of onset, although they differ markedly in the observed age at first conviction. It's also desirable, of course, to study sequences of onsets to investigate the probability of the onset of one type of offence being followed by the onset of another type. Stepping stones, if you like. I mean, for example, in the area of substance use, there's a well-known sequence going from smoking to marijuana to more serious drug use, and to some extent, marijuana seems to be sometimes described, smoking and marijuana seem to be sometimes described as gateway substances because they lead to other substances. But really, it would be interesting in research to look at onsets of different types of deviant behaviour, antisocial behaviour, and see the probability of one onset following another in these sort of sequences. Let me move on to another table showing the relationship between onset and the later criminal career, showing some linkages between onset and desistance. I'm sorry the figures are so small. Basically what this table shows is the number of people having an onset, a first conviction at different ages from 10 to 13, 14 to 16, 17 to 20, 21 to 32, of the total of 153 convicted males in our London study. It shows their total number of offences, and it shows that those with the earliest onset have the largest number of offences leading to conviction. So those first convicted at the earliest age in this table of 10 to 13 average 8 offences leading to conviction, whereas those first convicted at 14 to 16 average 5, those first convicted at 17 to 20 average only 2.4. And you see the same phenomenon if you look at average career length, duration of careers. Those starting at 10 to 13 have an average career length close to 10 years. That's between the first and last conviction. Those starting at 14 to 16, average career length of 8 years, and then it declines to only 2.7 years. Average age of the last offence is rather similar for these groups. It seems as though they all seem to finish around 22 to 23, which suggests that this decline in average number of offences and average career length is not an artifact of truncating the data collection at age 32 as we did. It's not just that the age 10 to 13 people have got more time to accumulate offences or to have their criminal careers, because they all seem to finish around 22 to 23. It seems that those who have an early onset have a persistent criminal career. They have a long criminal career with lots of offences. And that's a result that many people have found. An early age at onset predicts a long criminal career. This raises two alternative possible explanations. One is that an early age of onset is a symptom of a high criminal propensity, which later shows itself in persistent and serious offending. And an alternative theory is that an early age at onset in some way facilitates later offending. So if you have an early age at onset, perhaps that has a reinforcing effect. Perhaps it has a stigmatizing effect because it throws you together with other delinquents. But in any case, the idea being that an early age at onset predicts a later criminal career, either because of it's a symptom of a high underlying potential, or because the onset itself has reinforcing, magnifying effects. And in a recent paper, Daniel Nagin and I tried to compare these two different alternatives using Nagin's complicated models, which I would not attempt to try and explain today. But basically, he is partitioning out error terms into a term which reflects consistency over time and a true error term, and then he measures how important this consistency over time is. And basically what we found is that the link between early onset and later offending really reflects an underlying potential. It really is almost entirely attributable to the persistence of an underlying criminal potential, if we accept the Nagin models. In regard to desistance, which is the next topic I'm going to talk about, it's very difficult to measure, and it's a really under-researched topic. Lots of people have studied onset, lots of people have studied rate of offending, but very few people have studied desistance. Why do people stop offending? When do people stop offending? It's really difficult to know with certainty when desistance occurs, because even if you observe a gap of 5 years since the last offence, it's still possible that the person is a low-rate offender, and that this gap is a kind of probabilistic gap. As I say, assuming an underlying Poisson distribution, if you have a rate of offending, as the occasionals have, of 0.41 per year, you have an average gap of 30 months or so between offences, then having a gap as long as 5 years has a certain reasonable probability. It's not something that will be that unusual. So, but again, if you have a model, you can work out the probability of that sort of a gap. In research that I did with Blumstein and Moitra, we distinguish between what we call persisters and what we call desisters in trying to study basically persistence and desistance in criminal careers. There's a real danger of drawing false conclusions about desistance because of the truncation of data collection at a certain age. For example, if your data collection ends at the 18th birthday at age 18.0 and the last observed offence, the last observed conviction is at 17.9, you wouldn't necessarily think the person has desisted. I mean, that's the last offence, but you wouldn't want to treat that as desistance, but many people do. And so again, what you have to do, on the other hand, again, this depends to some extent on the rate of offending too, but if the last offence was a long time ago, then the probability that desistance has occurred is much greater. But anyway, what we did was to distinguish between persistence and desisters, and we developed two models. I call this persistence probability of the persisters we assumed was 0.87, and of what the people we call desisters, it was 0.57. That is after each conviction. What this means is that after each conviction, the persisters have a 0.87 probability of continuing their criminal career and having another conviction, whereas the desisters, perhaps that's a misnomer because this is quite a high probability, but they have a 0.57 probability. These are the probabilities we had to assume that best fitted the data. Again, we couldn't assume that everybody had the same persistence or desistance probability because that wouldn't fit the data. But once we divided the sample into two groups, the persisters and the desisters, then we could fit the sequences of convictions, the probability of one conviction following another. And yeah, I think I'll also mention the later work we did with Barnett, because we assumed both differences between frequents and occasionals in rates of offending and differences between them in probabilities of persisting after each offence. So you can either start with a model like Barnett did initially, which distinguishes only rates of offending, individual offending frequencies, or you can follow what I did with Blumstein, which focuses more on persistence probabilities after each conviction, or you can combine them and look at both, a slightly more complicated thing to do. What we assumed was that persistence or desistance occurred after each conviction with a certain probability. We could alternatively have assumed that it was a continuous process over time. In fact, one of the things we're doing now is to try and distinguish between those two hypotheses. I mean, either you can assume that after each conviction, each person has a certain probability of having another conviction or of stopping, or you can assume that desistance occurs as a gradual process over time. And to some extent, it's difficult to distinguish those two hypotheses on conviction sequences, but as I say, we're trying to do that. Let me just show you put this under here. Let me just show you an interesting diagram that we developed, which tries to help us to distinguish between whether people have persisted or desisted. Let's see if I can explain it. This shows basically the probability that someone is still active at age 25 given the age of their last conviction, and it shows it separately for occasionals and for frequents. So that if you're very close to age 25, if your last conviction is at age 24.9, the frequents in this model had a persistence probability of 0.9. So if your last conviction is age 24.9, all you can do is to look at that probability and say, well, you know, the probability they're still active, given that they have a 0.9 probability of being active after each conviction, is 0.9. We can't do any better than that. Whereas as you go farther back, if you have a frequent offender whose last conviction is at age 19, because these frequents commit offences at 1.1 convictions per year, 1.1 offences per year, if your last offence was at age 19, you must have desisted. There's no... The likelihood that you are still active is minimal. This is the likelihood that you are still, in your criminal career, still an active offender, that you have not desisted on the 25th birthday. Say if you're a frequent offender convicted close to the 25th birthday, it's very likely that you're still active. As you go farther back to age 19, because you commit offences frequently, the likelihood of your still being active at age 25 is minimal. Whereas if you look at the occasionals, they commit offences much less frequently, and the persistence probability is of the order of 0.6. So if their last conviction was close to age 25, if you're an occasional, there's about a 0.6 probability that you're still active. As you go farther back, you can't be so certain as with the frequents that they have stopped their criminal careers. For example, if you have an occasional with a last conviction at age 19, 6-year gap up to age 25, well, you know, their rate of offending is only 0.4 per year. They commit one offence every 30 months. It's not unreasonable to say there could be a 5 or 6 year gap. So back at age 19, if you're a frequent and your last conviction is at 19, you can be certain that they must have desisted. If you're an occasional and your last offence is at 19, then it's less certain that they have desisted. But by calculating these kinds of curves, you can work out the probability that somebody has desisted from offending, and what we did was to work out basically maximum likelihood models. So we said if the probability of desistance is greater than the probability of no desistance, then we'll assume as a first approximation that they have desisted. What we did, interestingly, was to carry out a predictive test of the model. We developed the model of frequents and occasionals up to age 25, And then we tested the model between ages 25 and 30 to see how far it could predict numbers of convictions between ages 25 and 30. What we found was the model predicted the subsequent number of convictions of the occasionals very well. The model did not predict the numbers of subsequent convictions of the frequents so well. And what was clearly happening when we looked at the frequents was some of these people whose last conviction was at age 19 and who must have desisted on the model, nevertheless were being convicted at ages 27, 28 and 29. And we were absolutely drawn to the conclusion that there must be intermittency in criminal careers for these people. In other words, on the model, given the high rate of offending in the teenage years and then an apparent desistance and then no more offending from, say, 19 up to 27, it must be true that they ended their criminal career at age 19 or 20 and then they reinitiated, then they started again. Because when you look at their career from 26 or 27 onwards, it's still a high-rate career. They're still committing offences at a relatively high rate. So we concluded from our predictive test that there must be intermittency in criminal careers, that some people, some of these frequent offenders, stop at a particular point, like 19 or 20, then there's a gap of 6 or 7 years, then they start again. And this is a phenomenon which hasn't really been thought about very much or investigated very much, but obviously it's important to know why they started again. Did they get divorced? Did they start getting drunk? Did they start being drug users, etc.? Yeah.
Did you look at the severity effect, like if the offenses got more severe over time or stayed the same or less severe?
Not particularly, no. I mean, we rolled all offences together. In general, what happens over time is that, over age, is that the offences get less serious in general.
Did you just look at felony offending?
These are all offences leading to entries in the Criminal Record Office, so they're roughly equivalent to index offences in the US. So it would exclude all motoring offences, all drunkenness offences, for example.
What about misdemeanor? All misdemeanor?
Your misdemeanor, well, it might include some, but not many. But it basically includes theft, violence, things like burglary, robbery, drug use, vandalism, fraud. Those offences. It's roughly equivalent to index offences, but slightly more inclusive. But again, this is a feature of criminal career research. Because you want enough data with official records, you generally roll everything together. Maybe it's a fault with it. But anyway, in studies I've done of average seriousness of offences, what you find if you follow through criminal careers, you find that the seriousness of offences increases from an early age and peaks about between 16 and 21 when you have a lot of burglaries and robberies. Then after 21 the seriousness goes down and you have a lot of theft offences. And that's also true of the penalties. Generally the penalties in a way get, it's maybe counterintuitive because you might expect penalties to continue to get harsher, but what tends to happen is that the penalties again kind of peak in severity from about 16 to 21 and then they become less severe. In England you get many more discharges, for example, in the 20s and not so many institutional prison sentences. So what you're getting in terms of seriousness is it's basically because you're getting peaking of burglary, robbery and vehicle theft, which are the most serious offences in this study, and violence. Burglary, robbery, vehicle theft and violence generally is peaking between 16 and 21, and then after that you're getting more theft offences. Before that you get more theft offences too. But anyway, the answer is in this analysis we didn't distinguish severity. Anyway, as I was saying, I think that intermittency is an important phenomenon which really needs to be investigated, and we, as I say, to some extent discovered that in our predictive test of this particular model. Let me move on to talk about chronic offenders. That's the next topic. Oh yes, I'm sure you've heard of the idea of chronic offenders, popularised by Wolfgang et al. In their book Delinquency in a Birth Cohort, pointing out that about 6% of the males accounted for about 50% of all arrests up to age 18. And this attracted the public imagination, thinking that if only you can identify those chronics and do something about them, then maybe you can have a big impact on the crime problem. Well, it all depends on whether you can identify chronics in advance. And what I'd like to point out is that if offences occur at random, and if you retrospectively add up the offences of the most frequent offenders, you're bound to get a disproportionality like 6% accounting for 50%. And here's an example of that with a very simple model. Let me put this away. If we assume that the probability of offending or re-offending is 0.5, and if we start off with a sample of 1,000, you will see 500 people go on to have one offence, so 500 have no offences. Of the 500 who go on to have one offence, 250 go on to have two offences, leaving 250 with one offence. Of the 250 who get to the second offence, 125 go on to the third offence, leaving 125 with two offences, etc. Very simple model. Assumes after each conviction, half of them go on to have another conviction. Entirely probabilistic, unpredictable chance processes say that half the people go on after each offence, arrest or conviction. What do we see with this very simple model? What we see actually, if we draw a line across there, is that 6% of our people, those with 4 or more offences, account for 31% of all offences. When we look retrospectively at this, if we partition off those with 4 or more offences, 6% of the sample account for 31% of offences. Retrospectively, we have chronics. Prospectively, we don't have chronics because we started off with 1,000 people. Each person has the same persistence probability of 0.5. Everybody is homogeneous. We cannot predict them, but yet we generate the disproportionality. And if I can generate the disproportionality with 0.5 and 1,000, well, that's 6. If I can generate 6% of 31% with that simple model, then it's very easy to generate 6% accounting for 50% with a slightly more complicated model, assuming no predictability. Because remember, the key issue with chronics is not the disproportionality, which you get very easily. The key issue is whether you can predict them in advance. Here, you cannot predict in advance because I am assuming everybody has the same persistence probability of 0.5. No predictability in advance, but nevertheless, looking retrospectively, I find 6% of the sample account for 31% of all the offences. So the key issue with chronic offenders is, can you predict them in advance? And merely demonstrating, as Wolfgang et al. Did, or other people do, that 6% of the sample or whatever account for 50% of all offences, retrospectively tells us nothing. Because with no predictability, we can easily generate that, as I've demonstrated in this particular diagram. So what we did in the London study was to try and develop a model for the persistence probabilities. As I said, we had this model here. We assumed the sample was divided into two groups of persisters and desisters, and 72% were desisters and 28% were persisters. I apologise if you can't quite see that, but that was the model. Basically, 3-parameter model. We chose the parameters to fit the data on probability of one offence following another. Persisters have a probability of 0.87 of continuing. Desisters have a probability of 0.57. 72% of the sample are desisters. With that model, we could fit the data very well of numbers of persons distributed over number of convictions. Again, here's the data. Again, I'm sorry if it's a bit small, but basically here's the observed number of people with each number of convictions. With K or more convictions. So we start off with 396 in the sample. This was excluding those who died. 131 went on to have one conviction. Of those, 82 went on to have a second conviction. 61 went on to have a third conviction. 42 went on to have a fourth conviction. This is the data, basically the data on continuation probabilities. Here shows our observed recidivism fraction, 0.33 of having a first offence. Of those, 0.63 go on to a second. Of those, 0.74 go on to a third. Typically, you find this kind of a diagram. You know, you have a diagram of probability of one offence following another. As you go from 1 to k offences, your probability of continuation increases. You'll see it's around 0.8 to 0.9 as you're going up to 6 or more, or up to 10 offences. And many people find this, that after the kth offence, your probability of a k plus 1th offence increases all the time. So this is the phenomenon we're trying to explain. Let's say we assume two populations, and we say let's assume that if we start off with a probability of 0.87 and we assume 28% are persisters, then here's the number of persisters who are going to be left at each conviction. Here's the number of desisters that are left at each conviction. You'll see that we start off with 36.7 persisters and 94.3 desisters at the first conviction, but then by the time we get to the sixth conviction, we have 18.3 persisters. Half of the persisters are still there at the sixth conviction, basically because 8.87 to the fifth is almost exactly 0.5 if you work it out on your calculator. So half the persisters survive to have a sixth conviction, but only 5.7 of the desisters survive because 0.57 to the fifth is actually 0.06. So only 6% of them survive to have a sixth conviction. So we predict 24 people still active at the sixth conviction. Here's the actual data, and you'll see, if you look at these two columns, you'll see we're fitting the data fairly closely. So in other words, assuming two populations of persisters and desisters, we can fit the data very closely. The key question is, so as I say, before, you see, I assumed everybody was homogeneous and I could generate a 6% and 31% disproportionality. By assuming two populations, it's very easy to generate the 6% and the 50% disproportionality. And indeed, that's what we see in the London data, that these 22 or 24 people, about 5 or 6% of the sample with 6 or more convictions, account for half of all the convictions. But we can entirely predict this by assuming two samples of people, one with a relatively high persistence probability, the other with a somewhat lower persistence probability. The key question is whether, not that we can model this, which we can by this underlying mathematical model, the key question is whether these people can be identified in advance. We can certainly model them by assuming that these are the underlying processes that are going on, that there are these two populations. Well, we also showed that you could predict these people in advance because we used a prediction score that was developed to try and predict delinquency in our sample. And let me just show you this overhead. Basically, this was a 7-point scale that was a score at age 8 to 10 based on 7 variables, 3 measuring troublesomeness and conduct disorder. Also, other variables were social handicap, which is basically deprivation, having a convicted parent, low non-verbal IQ, and poor parental child-rearing behaviour. I'll talk more about these things this afternoon, but all we need to know is that we had a 7-point scale at age 8 to 10. So everybody was scored at age 8 to 10 on this scale. And we then looked at the scores of people on this scale. As I say, this was developed to predict juvenile offending up to age 16. It wasn't developed to predict chronics at all or persisters. And we noticed that 28% of the sample scored 4 or more on this scale. And we thought, aha, that's interesting. Our model, to fit the aggregate data, said that 28% of the population were persisters. So what happens if we say, well, maybe those scoring 4 or more on the scale at age 10, let's assume that they're persisters. What happens if we look at the numbers of convictions over time? We start off with 37 scoring 4 or more, 95 score 0 to 3, and how many go on to have a second, a third, a fourth, etc. And if you compare the mathematical model with the actual numbers of these 37 people identified individually, these are 37 actual boys identified individually, you'll see a pretty good agreement here. That the numbers decline. That 10 of the 37 survive to have 10 or more convictions, according to the mathematical model saying 10.5 should survive. These are the persisters versus the desisters. According to the desisters, you start off with 94.3 By the time you get down to here, you have 0.6. Actually, you have 2 surviving to there. At this point, with, say, 5 convictions, 10 should survive. Actually, 14 survives. So when you actually look at people identified years ago on this scale, there seems to be pretty good agreement between the mathematical model developed retrospectively on the trying to fit the aggregate data and the real identification of people at age 8 to 10 according to their scores on this particular 7-point scale. So we thought maybe you can predict persisters, maybe you can identify persisters prospectively, whereas of course maybe you couldn't identify chronics retrospectively. But I think the important point of this demonstration is that it gives you a totally new picture of the idea of false positives. Let me just show you this. If we look at this 2-by-2 table and we say let's assume we're trying to predict chronic offenders in the London sample, those with 6 or more convictions. I said that those with 6 or more convictions account for 50% of all convictions in the London study. You'll see that of our people scoring 4 or more, there's 37 of them altogether who get a first conviction. How many have 6 or more convictions versus 1 to 5? Well, 15 of them went on to have 6 or more convictions. The other 22 fell by the wayside. They didn't survive to have 6 or more convictions. Of our people scoring 0 to 3 on the prediction score at age 10, 95 initially, let's see, 8 of them survived to have 6 convictions, 87 didn't. Those are the totals here. 109 makes 132. It's one more than the mathematical model because we included one man who died but who had 10 or more convictions. But that's a minor detail. Okay, now let's think about false positives. If we assume prediction is deterministic, we might say this has a very high false positive rate. We've identified 37 people on our scale as persisters. 15 of them actually became chronics. Well, we were wrong with 22. Our false positive rate is, I think it works out to be something like 59%. Equally here, we identified 95 as desisters, and 8 of them nevertheless became chronics. That's the traditional way of looking at false positives. However, what did we think of probabilistic prediction? Let me just digress for a minute. If I predict that the probability of rain today is 0.4, then the occurrence of rain or the absence of rain will not disprove this prediction. That's a probabilistic prediction. Probability of rain is 0.4. If it rains, that is not an incorrect prediction. If it does not rain, it does not disprove the prediction. How do I test this probabilistic prediction? What I do is I aggregate over time. So I say, let me identify 30 days when I say the probability of rain is 0.4. Now I can say what should be the total number of days on which it will rain. Obviously, if I identify 30 days when the probability of rain is 0.4 on each day, I would expect the most likely outcome to be 12 days when it rains by a simple multiplication. However, if the number of days on which it rains is 11 or 13, well, I know there's a certain, assuming a Poisson process, I know what the probability of that is. It wouldn't really disprove my prediction. It's only going to disprove my prediction if it's outside, let us say, 2 standard deviations, if you like, from the expected value. Obviously, if it rains on only 4 days out of 30, that would disprove my probabilistic prediction because that's very unlikely. It's like the one I just showed you. If you have a frequent whose last offence is at 19 and he gets up to age 25, it's very unlikely that he's still active. Same is true with all probabilistic predictions. You can work out what's the probability. Once we start looking at probabilistic predictions, we have a totally different view of false positives because we look at our 36.7 persisters on the model. The model says 18.3, only 18.3 survive to be chronics. That's the probabilistic prediction. It's not saying half of them are false positives. It's saying on the model, on the probabilistic processes, only half will survive. as I say, because 0.87 to the 5th power is 0.5, so we expect half to survive. Okay, well, let's try and say, how many errors in identification did we make? Well, actually, if we work it out, there is a discrepancy here. See, out of those 37, 15 survived. The model says half should survive. There is a discrepancy. Out of 95, 8 survived. The model says, well, just over 5.7. There is a discrepancy. And actually what you find is that you can fit the figures if you assume that of these 37, let me do another 2 by 2 table, of the 37 versus the 95, how many are correctly identified as persisters versus desisters? The answer is 29 were correctly identified, 8 were not. And the reason why I get those figures is because the probability of getting to the 6th conviction is 0.5 for these people. Remember, 0.87 to the 5th. So we multiply 0.5 by 29, we get an expected number surviving of 14.5. Probability of surviving for desisters is 0.06, remember, 0.57 to the 5th. 8 times 0.06, 0.48. We add together 14.5, 0.48. We get 14.98. That's the closest we can get to the observed figure of 15. So by knowing the observed figure of 15, we concluded that of these 37 with a scoring 4 or more, 29 were persisters and 8 were desisters. We were wrong on 8 out of 37, 22%. That's our false positive rate on probabilistic prediction. It's not 59%. We were wrong with 8. We weren't wrong with 22, basically because there are probabilistic processes. There's only a certain probability that somebody is going to survive up to the 6th offence. Similarly, for these 95, 5 were actually persisters, 90 were actually desisters. That's what you have to assume to get the actual figure. It's 8 as opposed to 5.7 because we have a few of the persisters. So we're wrong with 5 out of 95. We're not wrong with 8 out of 95. So once you look at probabilistic prediction, which is much more reasonable, I mean, really, it's more reasonable to assume some sort of a chance process or probabilistic processes. It gives you a different view of the world, at least in regard to false positives. The idea of false positives depends on the idea of deterministic prediction, which is really rather unrealistic. Okay, let me go on to say a little bit about career duration. I won't go on much longer, then I'll stop and invite comments. Oh yes, this was really going back to the previous overhead, I think. If I can find it. Yeah, onset and desistance. This is really focusing on career duration. I've already said that the average career length of these people is relatively long compared with the others. You really need to know what career duration is. For example, it has important policy implications in that if career duration decreases with age, then you don't want to incarcerate people for a length of time that's beyond the end of their criminal career. A very important criminal career parameter is the residual length of a criminal career. So if you take somebody at age 21, you say they're now an active offender, what's the residual length of their criminal career? How long are they expected to continue their criminal career before they desist? And if for that person aged 21 you say, well, the residual length of their criminal career is 3.5 years, and if you then incarcerate them for 5 years, in a way 1.5 of those years are wasted, because they're only going to continue committing offences for 3.5 years, 1.5 years are wasted. So you're wasting valuable prison space if you incarcerate people after their criminal careers would have ended anyway. So you need to know about residual lengths of criminal careers. And interestingly, when Blumstein has studied this, residual lengths of criminal careers seem to be fairly consistent over time. They certainly don't decrease with age very markedly. This is in samples of adults in the US. Residual length of criminal careers seems to be fairly constant, according to his calculations, certainly from age 18 up to age 35, which is an interesting phenomenon. Most of the estimates of lengths of criminal careers for offenders suggest that average criminal career length is around 10 years for most most relatively serious offenders. But I think what you need to do, certainly if you're from the point of view of a sentencer, will be to try and do research predicting residual length of criminal careers. And like intermittency, very little has been done on it. Very little is known about residual length of criminal careers. Let me just show you another one to demonstrate continuity in offending, because what you find is that the worst offenders at any one age tend to be the worst offenders at another age. Perhaps this is too complicated to show, but basically what this shows, it divides up the time period into roughly 4-year intervals. This is again with the London data, and it says how many people who are convicted in one interval go on to be convicted in another interval. So if we take the, let's say, 75 people convicted between ages 14 and 16, we find 25 of them were previously convicted between 10 and 13, 47 of them go on to be convicted between 17 and 20, 30 of them go on to be convicted between 21 and 24, etc. All this shows is a very replicable finding that you tend to get continuity over time in offending. Generally, the worst people at one time tend to be the worst people at later times, generally. So there's continuity between past and future offending. Let me just say a little bit briefly about specialisation. Most studies of specialisation in offending conclude that what you find is really versatility rather than specialisation. For example, in our London study, we had 153 males who were convicted up to age 32. Of these, 50 were convicted of violence. Of the 50 violent offenders, only 7 of them had no convictions for non-violent offences. So 43 out of 50 convicted violent offenders also had convictions for non-violent offences. So there weren't many specialised violent offenders, and indeed this is a very common finding. Furthermore, these 50 violent offenders, they committed a total of 85 violent offences leading to conviction, but they also committed 263 non-violent offences leading to conviction. They committed many more non-violent offences than violent offences. Again, a very common result. And I tested a model that assumed that violent offences essentially occurred at random in criminal careers, and the data was not significantly different from that model, suggesting that there wasn't really much specialisation in violence. Anyway, I thought I would show you a matrix developed in the Philadelphia study, because to study specialisation, people have generally used these kinds of transition matrices, at least in criminal career research. What this shows is the offences are classified into 5 categories: non-index, injury, theft, damage and combination. And this is saying on one arrest K, what's the probability of going on from, say, non-index to non-index or injury on arrest K plus 1. And you'll see for any type of offence K, the most probable offence on K plus 1 is a non-index offence. The second most probable is a theft offence. So generally, you see a great deal of versatility. In other words, the fact that you've committed an injury offence, i.e. a violent offence, on arrest K, well, you've got a 0.138 chance of an injury offence on arrest K plus 1, but it looks like generality, it looks like versatility, it looks like randomness, if you like. However, there is a certain degree of specialisation, because you can also see in any column the highest entry is the diagonal. So, for example, if we look at injury, probability of going to an injury offence on arrest K plus 1 is highest if you did have an injury arrest on offence K. And so what you see in this transition matrix, and indeed in all transition matrices, is the first thing that strikes you is versatility, but once you look at it a bit more closely, you see some specialisation. There clearly is some degree of specialisation. You see theft is the highest in that column, damage to damage is the highest in that column, etc. You see some specialisation, it's not very marked, but you see some specialisation which is superimposed on the prevailing versatility. And what we need is a method of quantifying the degree of specialization from 0 to 1. And I proposed an index called the forward specialization coefficient, very simple index, which basically applies to these kind of transition matrices. And it's very simple to calculate because it's just the observed value in a diagonal cell minus the expected value divided by the row total minus the expected value. And I'll explain it here. This is based on some data from that I did analyzing Maricopa County and Utah juvenile court records, and it shows a drug offense on the first juvenile referral to a drug offense on the second juvenile referral. What it shows is 1,269 persons had a drug offense on the first referral, 1,856 had a drug offense on the second referral, 28,201 in this study went on from the first to the second referral. It was a study of about 70,000 juveniles in these two places. 202 had a drug offense in the first referral and a drug offense in the second referral. So you say versatility. You know, out of 1,269, only 202 had a drug offense on the second. Out of 1,269 who had a drug offense on the first referral, only 202 had a drug offense on the second referral. However, the expected value in that cell, assume this is, again, a diagonal cell, is 83.5. So the number observed is considerably greater than the number expected by chance if there's complete versatility. Assuming the null hypothesis of complete versatility, you would expect 83.5 to have a drug offense on the first referral and a drug offense on the second referral. That's merely multiplying the row total by the column total dividing by n. RC divided by n, 83.5. Forward specialization coefficient is observed, 202 minus expected, 83.5, divided by row total, 1269, minus expected, 83.5, comes to 0.10. That figure is very consistently found in the literature, about 0.10. If there was perfect specialization and all 1,269 drug offenders on the first referral had gone to have a drug offense on the second referral, this would have been 1. Because then observed would have been the same as the row total. So it would have been R minus E divided by R minus E, it would have been 1. If this figure had been exactly chance, if it had been exactly the expected value, you'd have expected minus expected, it would be 0. So the forward specialization coefficient goes from 0, meaning chance, up to 1, meaning perfect specialization. The most common value found in these matrices is 0.1. Very common finding, which suggests that the degree of specialization is about 10% of the way between perfect versatility and perfect specialization. And that's a way of quantifying specialization. Other methods used are the adjusted standardized residual, which you can get out of your SPSS program with no difficulty. Actually, this is to some extent related to adjusted standardized residual, and also O divided by E has been proposed as a measure of specialization, but I don't like that because it doesn't go from 0 to 1, and that obviously is a better measure. So it's just a way of trying to quantify degree of specialization in these studies. I think I'll skip on to conclusions as time's getting on, and I want to give you a chance to ask questions. Just to say that I think research on criminal careers has considerably advanced knowledge about sequences of offences. Switch off. Future research should really aim to study more criminal career features, such as co-offending, whether offences are committed alone or with others, which I was going to talk about. I'll be happy to talk about if anybody's interested. Reasons given or motives given for offences, distances offenders travel to commit offences, etc. There's quite a few other features of offences that you could study and may be useful in predicting the future course of criminal careers. Also, future projects are needed which focus on self-reports where you get exact timings of offences because, as I say, virtually all the existing research is on official records. Let me skip over to one or two other points, if I can find them. The criminal career approach has important implications for criminological theories because existing theories focus very much on offending during the teenage years. They concentrate on factors that correlate with prevalence, either prevalence of conviction or with the frequency of self-reported offending in some cases. Therefore, the theories emphasize theoretical constructs that are particularly applicable to the teenage years, such as status frustration, or the strain between aspirations and what can be achieved by legitimate means, or peer influence for that matter. The implication of the criminal career approach is that theories should address developmental processes. Theories should try to explain why people start. Coming back to the beginning here, if I can show this again. Theories should be addressed to the different elements of the criminal career, not only trying to explain prevalence, trying to explain frequency, but trying to also to explain onset, desistance, duration, continuity, specialization, etc., not to mention co-offending and motives, which tend to be neglected in criminological theories. It may very well be true, and indeed some research I've done suggests it is true, that different factors predict these different criminal career features. For example, onset, which typically occurs in the early adolescent years, seems likely to be predicted by something like peer influence or absence of family control, whereas desistance, which typically occurs in the 20s, seems to be related, certainly for males, to getting married, settling down, breaking up with the peer group, or to moving house is another factor that's been brought into desistance, or actually also to probability of penal sanctions, because the penal sanctions become more important to offenders in the 20s than they were in the early adolescent years when they tended to neglect them. So it suggests that different factors influence different criminal career features. So if you're developing theories, you want to try and explain that. A short one or 2 points about policy implications. The distinction between prevalence and frequency directs your attention to different strategies for reducing crime. If prevalence is high, so you have offending thinly spread over the whole population, then your strategies should be directed really at the whole community. You should have wide-ranging educational welfare programs if prevalence is high and offending is widely distributed. On the other hand, if prevalence is low, offending is narrowly concentrated among a small proportion of the population, then you can focus more on criminal justice policies targeting known offenders, such as rehabilitation, deterrence, and incapacitation. Of course, there has been work on people defined as career criminals, it's been suggested that there should be a special incapacitation approach to those predicted as career criminals, but I think again, or those identified on the basis of their existing offending careers, but it's difficult to know how far you can identify people, as I said. You also need to know the relative effects of different sentences on aspects of the future criminal career. Given that you have one sentence as opposed to another, what's likely to be its effect on your future offending frequency, on your future duration, residual length of criminal career, etc. So I think criminal career research has important theoretical and policy implications, and I'll be very happy to try and answer questions.
I have a couple questions. What was the mortality rate of your cohort?
Of our cohort, 8 died up to age 32. Unhappily, it was the most delinquent and criminal ones who died first. And indeed,
just died. I mean, the ones, did you lose track of them?
Oh, lost track? No, not very much. I mean, up to age 32, at age 32, we were able to re-interview 94% of those who were not dead. So we only had 6% who refused to be interviewed. We found all of them after 2 years of assiduous effort. But I'll talk about that more this afternoon when I'm talking about the study. But we kept contact with 94% between ages 8 and 32.
And then my second question is you alluded to that the frequency is underreported, and that we should
Frequency is badly measured in official record studies. It's measured more effectively in self-reports. All the studies of self-reports suggest that there are some offenders with incredibly high frequencies of offending, mean, the typical finding you get is a tremendously skewed distribution, something like this, such that you have a few people, if this is lambda, if you like, rate of offending, and, sorry, which way around should we have it? Doesn't matter which way around we have it. Let's make that frequency of people, and we'll make this lambda. A very high rate of offending, you have very few people, whereas a relatively low rate of offending, you have a lot of people. I mean, roughly speaking, in terms of robbery calculations, I was just trying to remember the figures. It's something like, for robbery, it's about 93% commit 1 a year, roughly. About 6% commit 10 a year, roughly. And about 1% commit 100 a year, roughly. If you actually get self-reports from robbers, I mean, that's from reanalyzing the Greenwood data in California, Michigan, and Texas inmates. So basically, you have about 1% to a very high lambda people, very high rate offenders who you pick up in self-reports. You never pick up that rate in the official records because you can never commit 100 offences a year and get arrested for each one. You know, you get arrested after the first 2 or 3, even if you relate it to time at risk. You never get high rates of offending. So using official records, you get a false picture because with self-reports, you get a more accurate picture of the fact that you have some people who are really high-rate offenders. And, for example, in calculating the incapacitative effects of imprisonment, the results are very different according to whether you take self-reports, where it actually looks a lot better because you have these high rates, or whether you take official records where incapacitation appears to be a complete waste of time because you never have high rates.
Within self-report, though, how do you propose to more validly measure frequency of offending?
That's a good question. I would just say try and build on the research that's been done already using kind of diary methods with prisoners. I think to some extent the work with prisoners is really the best we have now, like started by Greenwood and continued by others using diary methods. The problem is, basic complication with prisoners is that they are not a random sample of the offending population, you know, because first of all you want to go back from the daily population to the entering cohort. That's bad enough because your daily population is disproportionately made up of long-term offenders, long-stay offenders. And so the daily population is not the same as the entering cohort of prisoners, which is a random sample of prisoners. Then if you can get back to the entering cohort of prisoners, you then got to go back to the sample of offenders, which are the people you're really interested in. And both of those steps are kind of complicated steps. So prisoners are not ideal from many respects, but I think the technology developed with prisoners could be used with community samples, and hasn't really, because if you look at the work with community samples, like, for example, the most common instrument used is the Elliott National Youth Survey self-report instrument. It's really useless for these kind of calculations because people are not asked in a kind of careful diary way about how often they do things, when they do things, etc. When did they last do it? When did they first do it? All those kind of questions you need for criminal career research. So I think you really need to take the Greenwood technology developed in RAND and further developed in further work with prisoners. As I say, I think really this has been developed best with prisoners, and you need to apply it to community samples because getting back from prisoners to the community is very complicated. So that's what I would suggest. I think that would be very well worthwhile as a research program. But you need to gear up your self-report research to criminal career research. And Greenwood did that. And research on prisoners has done that because they're interested in estimating incapacitative effects. And as I say, if you take official records, it's useless because it gives you such a false picture of the true number of offences people are committing. So you have to have self-reports. So I can see why the technology was developed by Greenwood and others who've followed the same approach. But whereas with self-reports with juveniles in the community, the interest there is really in working out basic prevalence and frequency. I mean, they're not really interested in criminal career parameters, or at least they haven't been. Elliott tried to disprove this in his presidential address at the ASC because he was so annoyed at these kind of accusations. But I think it's true, you know, that the usual self-report studies are not much use for criminal career research.
I was just thinking if we wanted to predict, based on a juvenile sample in school, if we wanted to predict who is going to be chronic offenders, I don't know any of juvenile that would keep a diary on the rate of offending. I just don't see that as a realistic...
No, I think you're right, but I think the challenge is, what are you going to do? You know, how can you develop it? I mean, maybe some juveniles would. Or maybe this, I'm not necessarily you should ask them to keep a diary, but maybe when you interview them, you can use special interviewing methods where you use, well, this is often done actually, where you say, you know, when was your birthday and when was Christmas, and when, you know, you use particular anchor points of significant days, and you try and get them to think how often per month did you do it, and all these methods can be used to try and maximize the validity of the data you're getting, as opposed to just saying, you know, how many times did you do it in the last year, which is a very difficult question to answer, you know. All I'm saying is I think there are technologies developed in the past and technologies that could be developed in the future to get better data, possibly from juveniles in the community or even from adults in the community. But I think we need that in the future. Generally, we haven't had it in the past. I don't think it's easy. I mean, I quite see your skepticism, and which is very reasonable. But all I'm saying is that's the data we need. I mean, we've all dealt with official records because they're there. You know, if we want dates of offences, they're there. We can get them easily for community samples. But we need really more detailed self-reports.
I just want to comment on that. I mean, with self-report, there's a money problem, but there's no reason why you couldn't interview them more often than one year.
That's true.
Once a month.
That's right. You could interview them once a month.
Money.
In theory. Unless you're going to
yeah.
exhaust the subjects, but
Yeah, there
could be some testing effects, you know, such that they learn after the first couple of times that they can minimise the length of the interview by admitting nothing, you know. So there would be obviously methodological issues arising, but I quite agree you could. I mean, indeed this has been done. I mean, you have daily studies. I mean, Reed Larson, for example, in social psychology, gets people carrying around a beeper. And he beeps. Every time he beeps, they have to speak into a tape recorder what they're doing at that moment. It's kind of event sampling and how they're feeling. It's to measure adolescents' moods. So that technology is available. So in theory, you could get everybody to carry around a beeper. You beep, and then you say, what are you doing at the moment? And a certain proportion of time, you'll be committing offences, you know. I mean, if Reed Larson can do that with adolescents, large adolescent samples, looking at adolescent activities and moods, I think he does get some delinquency actually out of it. But I mean, I'm sure there are lots of innovative technologies out there which may be possible, you know. But it's a question of developing. They wouldn't be cheap. I mean, it's a question of trying to develop them to get valid data. Yeah.
Did you interview these people at the end? I missed the first few minutes of the lecture. Did you actually interview the people?
Yes, I'm talking about that this afternoon, actually. But we had personal. I was focusing only on criminal career research in this presentation, but we did interview them on 8 occasions between ages 8 and 32.
I was curious about the group of people who ceased their behavior and then started back into that activity.
Yeah.
And how many what percentage of your sample actually fell into that category? And were these people not active, or did they just not get apprehended during that period?
Well, the first answer is the numbers are very small because the whole study was based on 85 offenders with 2 or more convictions. We had to restrict it to those with 2 or more convictions because we needed to estimate average lambda, average offending rate. So we couldn't just do it with 1 conviction. We had to do it with 2 or more, so we had an interval to calculate lambda. So that's 85 is the total sample. And out of those 85, 35 were frequents, right, as opposed to 50. Out of those 35, it was only about 6 who we observed this reinitiation. So I have to admit the numbers are very small. But it was, so statistically unlikely. We know, they must have stopped because they were frequent offenders. Say they started on average about age 16, then they had about 6 offences leading to conviction in the next 4 years, then they stopped. And then they started again on an average of 27, and then they may have had 2 or 3 more by age 30, which was the truncation. I did look at those individuals to see if I could find anything that looked obvious at the time, but I didn't see anything obvious. But I need to look at them again. I think we need to look at this again and see if we can detect anything about it, because I just think it's a new phenomenon, and obviously it needs to be replicated in larger samples. But if it's a true phenomenon, it's an important phenomenon.
Did you ask them about that, or
no? No, they were never asked about it because we didn't discover it until after they'd been interviewed. They were asked at age 32 when they were interviewed about what happened to them in the last 5 years, but I don't think really, again, we had retrospective self-reports, but we didn't ask them when they did things, as most people don't.
Your presentation about the false positives, I'm not sure I understood it. You could have a probabilistically perfect prediction,
right?
And you're going to have false positives, false negatives, because you've got distributions of offenders. The tails of the distribution is going to overlap.
Well, not really. No, it depends on the view of false positives. You see, let's come back to the idea of predicting rain. Let's say my prediction is that probability of rain is 40% on each of 30 days.
But that's not the way you do that. Because what you're doing is you're saying it's 70% 15 days and 10% 15 days.
Okay.
That's
all right. Well, I'm quite happy to do that as well.
Yeah, but that's a whole different thing.
Well, not really. No, it's the same issue. I mean, if you like, we can let's have for ease of calculation, let's have 40% on 30 days, and let's assume we actually see 12 days when it does rain, which clearly falls within, which clearly is within the expected range. And let's say we also say 80% on another 30 days, and we observe 24 days out of 30 when it rains, which is also within the expected range. We would say the probabilistic prediction is correct, and we can't really detect any mistakes in it. There's no mistakes in our assignment of probabilities to days. If we get within the expected range, we have not made any mistakes. And in a way, false positives means mistakes. So with that kind of probabilistic prediction, you could say there are no mistakes, there are no false positives. In our study, there were mistakes because we didn't get exactly the predicted figures. However, the number of mistakes was much less than on a probabilistic prediction than the number that appeared to be false positives on a deterministic prediction. See, the point is, it depends on whether you identify persisters prospectively or whether you're identifying chronics retrospectively. I mean, I can identify, assuming that offending, you see, all this assumes offending is a probabilistic or chance process. That's the basic assumption of all criminal career research. But assuming that offending is a probabilistic process such that there's a certain probability, like, let's say, we calculated for the persisters as a 0.87 probability of going on from one offence to the next offence to the next offence, then let's say we identify 30 people and we are 100% correct in identifying those 30 people, then because of probabilistic processes, only 0.87 of them will go on from the first to the second conviction. 0.13 will have only one conviction. That may appear to be a mistake. We've called these persistent offenders, and these people only have one conviction, but it's not, because it's fully predicted by the probabilistic process.
I understand that. And probabilistically, that's okay, but you can still have mistakes there and not know it, because the fact that you predict the right number of people doesn't mean that you predicted the right people. And even though it's a probabilistic process, we're not talking about a probabilistic phenomenon.
This is exactly.
You're talking about putting people in prison.
Exactly. Well, this is exactly why we did this thing that I showed you. See,
yeah.
Here's the probabilistic process where we don't know who the individuals are. This is aggregate data, fitting the data with a criminal career model, saying this is what we predict. We assume that, 72% are desisters, 28% are persisters. Persisters have a probability of persisting of 0.87. Desisters have a probability of 0.57. That's an aggregate model. Now what we do is we take individuals. Here we take all the people. They've all been rated at age 8 to 10. They've all been scored on a scale from 0 to 7. We can identify 37 individuals scored 4 or more, 95 scored 0 to 3. And we can look at their careers. These are the individuals. If we were absolutely correct that all those 37 had been persisters, if we were 100% correct in our assignment of people to categories, then half of them should have persisted to have 6 or more convictions. And you'll see only 15 persisted. The reason we were wrong there is because some of those 37 were in fact desisters. At least that's what the model would suggest. As I said, we made a mistake in that 29 of the 37 are persisters, 8 are desisters. That's our calculation. Similarly with that, we made a mistake. 90 were desisters, but 5 were persisters. We had some mistakes. That's why our figures here, 15 and 8, are different from our predicted figures of 18 and 5. But given that it's... All right, but that's the assignment of individuals. Here, you're quite right to say on the model, you're not saying anything about individuals. It's entirely a probabilistic model. Here, we do say exact things about individuals. This individual scored 4 at age 10. Therefore, we are identifying this individual as a probable persister. prospectively at age 10. And we are identifying these individuals as probable desisters prospectively at age 10. And then we can follow their careers through and see how correct we are.
If you take the distribution of that z-score there, that's some kind of discriminant function or something? The number was z, is that a z, is that what that says?
Yeah, well, no, z is just, it's probably a misnomer. We should have called it y or x. Just the number of the score. Score 0 to 7.
Whatever the score is. But if you take the distribution of offenses,
yeah,
for those from 4 to 7,
yeah,
and plot a histogram. Take the distribution of offenses for those in that group 0 to 3, plot a histogram. Those two histograms are going to overlap.
This distribution is almost identical to this distribution. This distribution is almost identical to this distribution. If you plot them, they are not significantly different. So, which validates the model, really, and also validates our use of this particular prediction technique, which we certainly didn't develop with the model in mind, because it was done many years before. I can show you I'll show you a little diagram where we plotted the graphs of expected versus where we plotted what the model says about the distribution of persisters versus the actual scores of those identified as probable persisters, and the two lines are almost.
I see that. That impresses me quite a bit. But when you start talking about false positives and about a probabilistic prediction, I get more confused.
Okay, what's the problem? You see, I mean, the point is, you see, you can partition people who drop out into those who drop out probabilistically, and those who drop out because you made a mistake in assignment to categories. In a way, false positives is where you make a mistake in assignment to categories.
Mm-hmm.
See, let's think of
I'm
incarcerated.
claiming you can't distinguish between which particular person.
No, we couldn't.
I can't tell you this person was a false positive because I'll put him in the wrong category, or this person was in the right category but didn't commit too many offenses.
No, we can't say that.
Well, and when you start talking about false positive, false negatives, you're identifying individual cases, and I just don't see how I can do that.
You can't say within these groups which ones did not persist because of probabilistic processes and which ones did not persist because of mistakes in assignment to categories. But nevertheless, you have these people. But all I'm saying is, if we, if we really took things to the extreme and said, let's say we're going to target people for treatment, and we start off with, let us say, 37 people we're targeting for treatment, and we find only 18 of them, say, persist to have 6 convictions, it doesn't mean we've made a mistake in giving our treatment. Doesn't necessarily mean we've made a mistake in giving our treatment to all 37, because it could be that all 37 were indistinguishable at the start, but because of what we say are probabilistic or chance processes, some do not persist and some do, but all could have been identical at the start. Again, we're using the word probabilistic to mask our ignorance, because really these processes could refer to, opportunities, peers you happen to hang around with, likelihood of getting caught by the police. I mean, we're kind of rolling all our uncertainty into the word probabilistic processes. So that's the theory behind it, really.
I have one other question that's kind of shorter. With the stuff you had about the specialization with the drug offenses.
Yeah.
I don't know if police departments specialize, or police officers or teams specialize in England as much as they do here. But is it possible that kind of specialization with the next offense being a drug offense reflects specialization of police as much as it does a criminal career? Because once you're arrested by a narc, then narcs are never going to leave you alone. And you'll be arrested for the same offense again.
Well, all I can say is that in our London study, we worked out these transition matrices of offence type from one conviction to offence type to the next conviction, and the transition matrices were very similar for official data and for self-report data. So I know in our study transition matrices are almost identical in terms of transition probabilities that you see from type of offence, let us say, on offence K to type of offence on offence K plus 1. So I don't know that would necessarily be true, given that you get the same transition matrices.
Probably not.
Yeah. I don't think it's all I mean, the continuity over time is not entirely produced by a continuity in police reaction, because of the similarity between official records and self-reports.
I know your sample was all males, and I assume that it's pretty homogeneous on race, too.
Yeah, 97% white.
Yeah.
You see, it was as I'll explain in the next session this afternoon, it's basically all the boys who were aged 8 to 9 in 6 adjacent primary schools in 1961 to 62. So it's all the boys in one small area at one particular time. So it's kind of a complete population of a small area. So there were very few blacks in that area at that time.
I wonder if you know any research that's being done in this area that suggests that something different. You might find something different if you had blacks and Hispanics, or if you had females in there. Is there any evidence that it would be different, or should we assume?
No, I think the answer is there's virtually no research on females because the rates of official offending are so low with females. It's not done. However, obviously it could be done on blacks versus whites, but I'm not sure. Obviously you could predict various things. Basic things will be known, like age of onset we know is lower for blacks than whites, for example. I don't know about desistance, but it would be interesting to compare blacks and whites systematically on these different criminal career parameters. I can't think offhand of anybody who's done it, but I think in principle it could be done.
Have you thought about that theoretically? Do you think there would be any reason?
Well, I don't know. You see, this would depend on developing theories to explain onset, for example, or to explain persistence after onset, or to explain desistance, or to explain specialization. And really what we've got so far is really more specification of the particular processes. We haven't got much in the way of research on what explanatory factors would influence the processes. That's the next step. And the next step is what explanatory factors influence onset, persistence, desistance, etc. And then perhaps the next step after that is to say, well, do we need different theories for males and females? Do we need different theories for blacks and whites? Or can we have the same explanatory factors? But really, until we develop some explanatory factors, it kind of, that's the next step, I think.
Well, kind of connected with that, I was kind of interested, especially when you're talking about the occasional, because I'm interested in the theoretical development of this part of onset versus continuation, for example. And on the occasional, it got me wondering if, they do things so rarely that, or so infrequently that it's always like an onset decision each time. And it might be peer influence each time. And while for the frequent guys, frequent people, there might be really differences between onset causes and continuation causes.
Well, it's an interesting idea. That would be a different framework. I said the criminal career approach is a framework. Yeah. The framework says you have an onset, you continue, you have a desistance. That's the framework. Yeah. What you say is kind of a different framework. It may be more realistic. It would be interesting to look at.
Well, for occasionals, I was just thinking, you get with that one friend once every 2 years and y'all go out and get drunk and get in trouble.
Yeah, so you're saying, is it realistic to use the term criminal career if it really is so occasional? Yeah, well, again, the interesting thing will be to look at self-reports and to see whether those one offence every 30 months is kind of 1 out of every 10 they commit, and that they're perhaps committing them more consistently than that. I think that's why a more widespread use of self-reports will be useful, I think.
Was the the calculations for persisters and desisters and stuff, anything, was incarceration?
Yeah, we took that out. Any time not at risk because of incarceration was taken out in the calculations. Yeah, we did that.
What about if they were on intensive supervision?
No, we'd include that. If all we took out was times incarcerated. So any time under supervision, they were still in the community.
In here, I know we have different levels of intense supervision. Do y'all have? Is that a frequent?
Not really. No. It's. Either you. Well, there are problems. Like, for example, when our juveniles were in, say, between 10 and 15, they would go to places called approved schools, which is an institution, but it's doesn't have a big wall around it, and so there's a lot of absconding from approved schools where you steal a car, and usually leads to further offending. But we counted that as being incarcerated, But it's a problem, really. It's not like a prison where you really don't get out. It's so we did have those kind of difficult decisions to make, but I think that's the nearest to what you say. Oh, why not?